Hello guys, today's video will be a quick one. It will be a continuation on the previous two ones, which talked about controlling vectors, motors, and motions. I will basically introduce you to new functions and methods of the API that will allow you to control vector movements more easily. But first I will show you a few things. It has to do with upgrading the SDK or updating it, because if you've been around at the forums, um, you may have noticed that there are some features that are not currently implemented in the SDKs, like for example the audio, and which the developers, Anki's developers, are planning to release sometime soon. So if you want to know if your SDK is old and if it needs to be updated, just go to the CMD and you can type in pip, if you remember, which is the same command that you use to install the SDK. And you want to list all the outdated, and wait for it. And you should basically get a list of all the packages that need update, and you can see that Vector SDK is not one of them. So currently we have the latest one. Okay, let's get started with the actual video now. Let's go to the API page, and the new function that I'm talking about are under the behavior class. Before we start talking about the functions themselves, here are four constants that you will find very useful when dealing with vectors motion. The first one is the maximum head angle, minimum head angle, maximum lift height, and the minimum lift height, which are basically like the limits for controlling the head and the lift. You can see that vector can lift his head up to 45 degrees up and minus 22 degrees down. The arm will go to a 92 millimeter, which is like 9 centimeters high, and when it's lowered to the maximum, it will be 32 millimeters high from the ground. But the functions that we are most interested about are first the drive straight function. Now this function will take a distance, a speed, and whether it should be playing some animation or not while moving. But the most important parameters are the first two. And as you can see, the distance and the speed are not like simple double or integer values. They are actual distance and speed objects. So if you want to use the drive straight function, and you want vector to go 20 centimeters forward, which is 200 millimeter, then you will provide the distance underscore millimeter, and then you will give it the value in millimeters that you want vector to move. Now I'm mentioning this because you might, if you look quickly at the method, come and type in. I will start typing myself. This is the code from the last video. I'll just delete it. So you might come, say vector.behavior dot move, or what was it, dot drive underscore straight. And you might be tempted here to say I want him to go 200 millimeter forward, but this will not work, because let's try to build it and it should give us an error. Yes, because we're missing an argument, which is speed. Let's say you want him to go 200 millimeter forward at the speed of, say, 20 millimeter per second. Now if we run it, we'll still get an error, but this time the error is that there is no attribute which is speed in millimeter per second. We actually have our speed, but it's in the wrong format, as well as the distance, because they need to be in speed and distance object representation and not in simple integer, double, or float representation. To do so, we use methods that are called distance underscore millimeter. Now if you try to use this immediately, you will notice that there is an error, because we need to import this from the Anki vector util package. Now if you import it, it will be working. And here, I think there's a speed underscore millimeter, and we can, nope, millimeter per second. And now we can import it and we should be fine. A quick trick if you want, as you can see, when the IDE automatically imported those functions, it's saying that from Anki underscore vector.util, we want to import these two functions. But say that we're using 10 functions, this will look ugly, and say that I don't want to import every function that I want to use every time. You can just delete them and replace them with a star. Star is basically a wildcard that tells the IDE to like import every function and every constant inside of utils. Okay, and now let me point vector in a way that will not fall. And if we run it, you can see that it's working. Yeah, apparently 20 millimeters per second is too small of a speed. Okay, we'll wait for him to... Okay, and it's done. The next function that I want to talk about, let's stay with the wheels. Yes, the turn in place function. Now basically this function will make vector turn around himself. It will take a couple of parameters. Not all of them are a must. Basically the only one that you should be specifying is the angle, but it's good to know what the rest of them do. So you also have the angular speed at which to turn, as well as the acceleration. You have the angle tolerance, like what's the minimum error that should be present before we can consider that vector is at the correct angle. And the is absolute, true to turn to a specific angle, false to turn relative to the current position. So if this is true and vector is currently at an angle of 10% and you tell him to rotate to 10 degrees, and tell him to rotate to 20 degrees, then he will rotate only by 10 degrees. But if it's false and it's not absolute, it's relative, then the vector will turn from his current position 20 degrees, which will make him become at the 30 degrees angle. There's also the number of tries, so if there's like an obstacle or I don't know, anything that might be preventing vector from turning, this will specify the number of times that vector will attempt to retry on turning before he gives up and just stop executing the command. Now here as well, the angle is actually an angle object and it is not an integer or a double. And to create an angle, you use the degrees function, which also is part of the utils, which we previously imported. So now if I come here and say vector.behavior.turn in place, and I want you to turn degrees and 90 degrees. And as you can see, the IDE did not complain because we already imported all the functions inside the utils package. Okay, the next function we'll talk about. Okay, let's talk about the lift. The set lift height, it takes, similarly to the turning and the driving, it takes the height to move to, the acceleration at which to move the lift, the maximum speed to reach, the duration, and the number of retries. So I think all of the parameters are self-explanatory. And here actually the height is a float, it's not an object, so you can directly write set lift height and give it a float number. But there is a trick here, so the number should be between 0 and 1. 0 meaning that you want the lift to be at the bottom and 1 to be at the top. Now I've tried this and you can give it actually a number that is higher than 1. So if we say vector.behavior.set lift height and we say 1, this will lift it to all the way up, but if you say 10, this will do the same as well, but you will get a warning message in here. Maybe I'll try to show you. And if we run this, okay, actually vector moved the arm up, but yeah, you will get this warning message here. So you should stick to a range between 0 and 1. Now say that you want to move the arm up to a certain height, not just typing in a normalized value between 0 and 1. I would say this would be a good exercise for you to do. Maybe come here and define a function, let's call it normalize height. This function will take the height that you want to normalize, and it's gonna return the normalized height. So if I give it 32 millimeters, it should return 0, and if I give it 92 millimeters, it should return 1. And this way you can come in here and say normalized height and give it the height in millimeter that you want, for example like 50 millimeters. I think I will post a solution to this in the next video. It's actually a very simple calculation, and I'm sure most of you will know how to do it mathematically. So if you're new to coding, this will be like a good exercise to practice on your own. Let's move on to the next, and I think it's the final function that we'll cover, which is the set head angle. Now the set head angle, very similar to the set lift height. It takes an angle, an acceleration, a max speed, a duration, and a number of retries. Actually, all of them are the same as in the set lift height, but the first parameter, which is an angle, like for the turn in place, this will take an angle which is between the minimum head angle and the max head angle, which I showed you previously are 45 and minus 22 degrees. I will quickly write the code for this. So you'll say vector.behavior.set head angle, and you're gonna say degrees to convert your number into an actual angle object, and say I want you to rotate to 40 degrees. And let's run it. And it executes correctly. And this should be it for this video, guys. I thought I should make a small video covering these functions, because we covered on how to control each motor individually, which is like a lower level control over vector, but these functions could be useful too if you wanna prototype quick movements. They will be very useful. Please, if you have any suggestions for the coming videos, don't hesitate to tell me. Actually, I've created a small post on, I think, maybe here. Yeah, so I'm thinking about doing one of these videos. So if you have any suggestion other than these, or if you prefer one over the other, then we can do this. I think in this video we already covered this. So it will be between how we can use Alexa maybe to control vector, maybe saying something like Alexa, and then say tell vector to, for example, dance, and then it will execute our custom dance script that we wrote earlier. Or maybe we could go with learning how the display of vector works and how we can show our own images or maybe animation. Anyway, thank you for watching, and see you in the next one.